So this time we will talk about the definition of the derivative of a function, and then we also cover more examples. Okay, so the previous video we talked about the definition of tangent line equation is m tangent equal to fx plus h minus fx over h. Oh, I forgot limit. So limit h move to 0. Fx plus h minus fx over h, right? But so the writing m tangent all the time is pretty hassle and complicated. So we want to simplify and make as a function form. So now basically tangent line slope formula we are calling as a derivative. Okay, so from now on you must remember whenever I talk about derivative, which means we are finding equation of tangent line slope. Okay, so you must remember this way. Derivative means finding equation of tangent line slope. And then now it has many different ways to indicate. So first of all, I can write f prime x, and then we can also say dy over dx, and then sometimes it's given as a y, then you can also see y prime and d over dx, and then we can say fx and something like that. Okay, so we may using the most case this notation and this notation, and few case we may use this notation here. And then as you see, this is kind of part of this one, so I'm not going to review that. Okay, so now instead of writing m tangent, or another word, slope of tangent line, I can say f prime x equal to limit x move to 0 fx plus h minus fx over h, like that. Okay, then let's continue some examples. So example 1, so find f prime x for fx equal to root 2x and use the result to find the slope of fx at the point 1 and 1 and 4 and 2. Okay, so remember f prime x means tangent line slope, which means you need to find out slope for at the point 1 and 1 and the 4 and 2 both. So two different cases anyway. Okay, two different questions. So don't think you are using those 2 points and find the secant line slope. Okay, so let's find the f prime x first. So f prime x becomes fx plus h minus fx over h. So don't forget limit h move to 0. Okay, then now we are finding fx plus h, which means square root x plus h. So now we can complete this form. So f prime x equal to limit h move to 0 square root x plus h minus root x over h. So unfortunately, the numerator become irrational and denominator become rational. So we assume h moved to 0, which means rational. So we cannot do any more. But as you see, you plug 0 into h here, and this become undefined. So this case, we wanna just multiply conjugate of numerator expression, and then we try to simplify again, so that the denominator wouldn't be 0 anymore. Okay, so multiply conjugate, which means root x plus h plus root x on the both numerator and denominator. Okay, Then this becomes limit h equals to 0 now. So x plus h minus x over h times square root x plus h plus root x. So you may wonder why I didn't FOIL this time and then just write x plus h minus x, because I'm using the factoring forms. A squared minus b squared equal to a plus b, a minus b. So please remember this factoring form because you will use it a lot. And then now I simplify the right term, then this is gone. So this become limit h move to 0, h over h times square root x plus h plus root x, and we simplify the common terms between numerator and denominator. Then this becomes 1 over root x plus h plus root x. So now even though you plug 0 into h, that it wouldn't be 0, so you can plug it. Therefore f prime x become 1 over 2 root x. That will be the derivative function for the given function fx equal to root 2x. Okay, so let's find the slope at x equal 1 and 1 and 4 and 2. So f prime 1 equal to 1 over 2 root 1 becomes 1 over 2, and then at 4 and 2, then f prime 4 equal to 1 over 2 times root 4, which is 1 over 4 basically. Okay, so those two are the answer for this problem. But one thing I was wondering, what if the given point 0, 0? So we just look at the GeoGebra graphing module, and then let's check what happened here. So this is the root x graph. Now, do you remember when is the case limit exists? So now we have the point right here. Right here, then we definitely able to find the limit, because now on center of this point we can find limit from the left side and then right side. Okay, so basically limit means, you know, the function must be continuous. And now at this point, this origin point here, so this one looks like basically the starting point, so that if I'm using the whiteboard here, so think about how many tangent line equation you can generate. It can be so many different ways. So there can be one, you know, maybe this can be another one, it can be another one, it is also another one, because, you know, this is kind of a starting point. There's no such line exists beyond negative side here. So there's so many tangent line exist, and then it is also passing through one point. So at 0 and 0, so we cannot determine, basically undefined. Okay, make sense to you? All right, so that's all this video, and then next video we will talk about the rational function case. They find the f prime function for the rational function, and if time is allowed, then we can cover more.